下次我们这个名牌就不会再贴了，所以你记住你自己的座位，还有记住这个跟车顶的，所有发的 exercise 你最好下堂课都带上，因为总是有同学找我要，所以不要带上。因为我回去说两句。如果你们已经交了，然后那个背面有题目，所以你们下面回去之后就自己找原子。对，往前看网上。
Okay, so just a clarification for this question. You let v1, v2 up to vk be a set of a length and column vectors such that each pair is perpendicular. So I agree it's a small technical detail, but then as two students have already pointed it out, assume that all these vi's are non-zero. So you can change the question to let v1, v2 up to vk be a set of non-zero length n column vectors. Okay, so we have a solution for one of the problems. So the problem is, if V1 through Vk are a set of non-zero length and column vectors such that each pair is perpendicular, then the dot product is, that is the dot product between any pair is 0, then they are linearly independent. So here is the argument. So the argument is by contradiction. Suppose that there exists a set since they are linearly, so if they are linearly independent, then there should be some constants C1, C2, C3 up to Ck, such that not all of the Ci's are 0, such that C1 V1 plus C2 V2 plus so on plus Ck Vk is equal to 0, and at least one of these Ci's is not 0. So choose an I such that Ci is not 0 and take it to the other side. So C1 V1 plus C2 V2 plus so on, except Ci Vi can be written as equal to minus Ci times Vi. Now you use the property that the Vi's are perpendicular to each other. So multiply both sides by Vi transpose. Since Vi is perpendicular to all other vectors, Vi transpose V1 is 0, Vi transpose V2 is 0, and so on. Vi transpose Vk is 0. So the left hand side becomes equal to 0. On the other hand, the right hand side, we know that Ci is not equal to 0, and Vi transpose Vi, which is the squared length of Vi, is non-zero. So the left hand side is 0, but the right hand side is non-zero, from which you arrive at a contradiction. Therefore, they must be linearly independent.
这个题是让证明我们现在有一个长度都为 n 的这样一个行向量的集合，然后并且证明这个集合里所有向量元素都是互相垂直的。然后他现在要我们证明这些元素一定都是这个线性不相关的。然后我们就是直接证明是比较麻烦的，所以考虑用反证法。然后我们先假设就是它们是线性相关的，然后依据这个假设，我们可以得到一定存在一个非零的 n 元数列 C1 一直到 Ck， 使得 C1 乘以 V1 加上 C2 乘以 V2 一直加到 Ck 乘以 Vk 这样一个线性组合是等于0的。然后并且这一个非全为0的 n 元数组，那么既然是非全为0的，我们一定可以从中取出一个非0的数，然后我们比如说是 Ci， 那么我们将上面这个等式中取出 Ci 乘以 Vi 这一项移到等式的右边，然后就可以得到这个等式，然后我们再在这个等式上，然后再乘上有两边同时乘 Vi 的这样一个向量的转置向量吧，好像是，然后就可以得到下面这两个等式，就是左边的是因为这个 Vi 这个向量和这个其他所有向量都是垂直的，所以左边就等于0。然后右边呢，因为 Ci 不等于0，而 Vi 的转置乘以它本身是它的模长平方，所以这个东西一定不是0。然后刚才教授也声明了，就是这样一个集合中的都不是零向量，所以说这样就矛盾了。然后我们就证明出来，它们一定是线性不相关的。然后这个题上还有一个 argue， 就是说这个当写紧张这个条件成立是在这个 k 小于等于 n 的前提下。然后这是陈宇的一个证明，就是当 k 大于 n 的时候，它们一定是线性相关的。然后这个其实是用到了一些定理，但是是比较就是浅显的吧，算是不是浅显，就是比较就是依据课本定理是议证的，就是这样啊。完了。
So are there any questions? Everyone has understood the solution?
Thank you.
Please take some chocolates. Okay, so we have a solution. We have a solution for the last problem. So again, this is using contradiction. So to solve this problem, you use the following property, that the rank of A is equal to the rank of A transpose. And so the proof is by a contradiction. You prove that you suppose that the matrix A is such that both the row vectors and the column vectors are linearly independent. So if either which means that the rank of A is equal to M, so there are M linearly independent rows, and the rank of A transpose should be equal to N.
Yep.
So if you assume that rank of A is equal to rank of A transpose, then it means that M is not equal to M, which is a contradiction. So it's not written properly here, but this is better. So if both the row and column vectors are linearly independent, then the rank of A is equal to M, and the rank of A transpose is equal to N. However, rank of A transpose equals the rank of A, therefore M is equal to N, which implies that A is a square matrix. So, but this contradicts the fact that A is not square. Hence, this must mean that M is not equal to which means that either the row vectors are linearly dependent or the column vectors are linearly dependent.
然后我用普通话简单的说一下，就是这道题我们用的思想和刚才那种是类似，也是用一个反证法。然后我们先假设它这个命题的后面的这个结论的相反的这一面，就是 row vector 和 column vectors 都是 linearly independent。然后因为它是 linearly independent， 所以我们可以得到 rank A transport 等于 n， 也就是它的列数，然后 rank A 等于 m 等于它的行数。然后对于任意一个 matrix， 我们有一个性质就是 rank A transport 等于 rank A。然后从这个可以推出 m 等于 n， 这就意味着它是一个 square matrix。然后我们都知道，在逻辑上有一个逆否命题的和原命题的真假性是一样的，所以说它的逆否命题就是我们题目中的那个命题是真的，大概就是这个意思啊。对。
So questions? The column rank equal to row rank. It looks like we don't have time, but that is a bonus question. So does anyone have a solution for that? Can you post it on Piazza? Okay, so if any of you have solutions to either of the bonus questions, bonus question 1 or 2, then please post it on Piazza. We'll take a look. So we are out of time. So for now, please hand in the solutions for these 3 problems. You can hand in the solutions for Gram-Schmidt orthonormalization in the next class.